Welcome back. Today we're looking at spectrometry. What is it, and how do we use it in astrophysics? If we look at the word spectrometry, we can break it into two. Spectro comes from the Latin word specere, which means to look, and metry, which comes from the Latin word metria, which means to measure. So what we're doing is measuring and looking at things around us. And today, we're going to make our own spectroscope. These are the materials you'll need: paper, toilet roll, a blank CD, scissors, sellotape, and a pencil. The first step is to trace a circle around the toilet roll onto the piece of paper. You're then going to want to cut it out and now cut it in half so you have two semicircles. Next, we're going to attach each of the semicircles to the top of the toilet roll, making sure to leave a gap in between. This gap is going to let light into the tunnel that is the toilet roll. It helps to stick down each semicircle one at a time, and we're just using some sellotape to do that. Yeah, and just make sure you have that small gap, very thin, and that might take a bit of moving around. Lastly, you just want to secure all the tape you've put on with an extra piece of tape around the side of the toilet roll. This is what it will look like and what it looks like when you look inside. And that gap is just letting in a small amount of light that we're going to later look at. Next, we're going to take our CD and with a scissors or a sharp pencil, make a small scratch just on the white side. Then using a piece of tape, put it over the scratch and peel it back off, and that should remove some of the foil. We just want to make a small gap, small enough to see through. When using the spectroscope, you want to hold the CD to your eye and then place the toilet roll on top. So if the eye was the camera, this is what you would see. This is what you would see if you point the spectroscope at natural light, like a window, being very careful not to point it at the sun directly. As you can see, the light is made up of all of the colours of the rainbow. Just as droplets of rain disperse natural light into its different colours in a rainbow, so does the little grooves on the CD. If we were to point it at, say, a light bulb inside of our house, however, you can see that it's more artificial in the sense that all of the colours are there, but it's not smooth. Someone's been making white light. It hasn't occurred naturally. Now, if you hold your spectroscope up to the screen on one of these coloured squares, you should be able to see what colours go into each square. Our ideas of mixing come from paint, but light doesn't work in the same way. If we look at the yellow light, we can see that it's actually made up of red and green. Primary and secondary colours of light are not the same as they are with paint. So I'll give you a chance to do some detective work and figure it out. And pause if you need more time. Now you might be wondering what spectrometry has to do with space and astrophysics. And that's a very good question. Not only can we see what colours make other lights, but we also know that different materials or elements glow a particular colour. This happens when the electrons inside are given energy and they lose it as light. just like in this picture of the Northern Lights. The famous glowing colours come from what's inside the air. So the green that we see is coming from the oxygen in the air, and sometimes you see purple or blue, and that comes from nitrogen. And what's happening is that energy coming from space, radiation, is exciting the electrons inside of the atoms and giving off this glowing colour. With this information, we can look to faraway stars and analyse the light that comes from them. This can tell us what the star is made of. And passing by planets affect this light, so sometimes we can then tell what the planets are made of and possibly understand if they're habitable. The information we get from the light is called spectra, and this is a little exercise. On the top line there's different spectra belonging to different elements, and on the bottom there's 4 examples, each of which contain 2 of the above elements. Again, you can use your detective skills to figure out what each one is made of, and also which ones contain elements that are important to life. Pause now before I reveal the answers. Number 1 is hydrogen and lithium. Number 2 is carbon and nitrogen. Number 3 is potassium and sodium. Number 4 is boron and oxygen. Some of the most important elements for life are oxygen, to breathe; nitrogen, it's in the air; carbon, it's what we're made of; and hydrogen, which is the most basic element, a really important building block. These are the elements that we look for in space when we're trying to figure out if other planets are habitable, or if there's a possibility that there's life on these planets. We hope that you learned something new about spectrometry today, and about a really important tool that astrophysicists use that maybe you hadn't heard of before. Thanks for watching, and make sure to subscribe.